Hello students, how are you? I hope you all are doing fine. So students, before starting our new chapter, let's dive into the magnetic world of magnets. For this, we will perform an activity. Students, for performing this activity, you will require some metal pieces, a sharpener cover, a stone or a pebble, plastic objects, refill caps, these are made up of plastics, chalk and iron filings. These are crushed iron filings, as you can see. And the most important thing which we require for this activity is magnet. Students, as you can see, this is a magnet and this is also a magnet. You can see their shapes are different. This magnet is known as horseshoe magnet and this is bar magnet. We also call this U-shaped magnet. Now, I will put all these things inside this glass bowl. I'll be putting pen caps, some metallic objects, cover of sharpener, metal pieces, chalk, stone, some plastic pieces, sharpener and some iron filings in the bowl. You can see I am going to mix it. Now I will take a magnet and rotate it inside the bowl. You can see some objects stick to it. Now the other magnet, bar magnet, you can see some objects get stick to it at the poles, but some other objects like plastic, stone, sharpener which is made up of plastic, sharpener cover which is a paper and a chalk, this doesn't stick to it. Do you know the reason? Students, the objects which gets pulled towards the magnet or gets attracted towards the magnet are magnetic objects like metal, iron filings, but the objects which do not get attracted towards the magnet, they are non-magnetic objects like plastic, sharpener, paper, stone or wood. These are non-magnetic objects. So students, now let's explore the world of magnets through our chapter 4, Exploring Magnets. So let's begin with lesson 4, Exploring Magnets. Before starting the chapter, let's know about the history or the discovery of magnetism. Magnus, a shepherd, was grazing his flock in Magnesia, which was in Greece, when he noticed his iron-tipped staff sticking to a rock. The rock, known as magnetite, was a natural magnet, and this was the first recorded discovery of magnetism. For the activity which we performed earlier, yes, from that we can define a magnet. A magnet is an object that can pull certain materials like iron or steel towards itself. As you can see in the picture, some materials are attracted towards the magnet. Other materials like iron bars, nails, coins, pins, they get attracted towards the magnet. So a magnet is an object that can pull certain materials. Not all materials are pulled by magnet. Students, the materials or objects that were attracted towards the magnet, they are known as magnetic objects like iron, nickel, cobalt, or alloys like steel. As you can see, the screws which are made up of iron, the coin, these are magnetic objects. The reason these materials are magnetic is that their atoms can easily align to form magnetic domains. As you can see, the nails get attracted towards the magnet, coin gets attracted towards the magnet. So these are magnetic objects. When we were performing activity, you must have noticed some material does not get attracted towards the magnet. These were non-magnetic objects like paper, wood, or plastic, which we have used in the activity. So these materials were magnetic, which were attracted towards the magnet, and non-magnetic, which were not attracted towards the magnet. So we can differentiate between both of them, magnetic and non-magnetic materials. There are different types of magnets, as we have used in the activity also. The first one is horseshoe magnet. It is U in shape. It is also called U-shaped magnet. The second one is bar magnet. It is like a bar. And the third one, the ring magnet. It is shaped like a ring, circular ring. So we can classify magnets as horseshoe magnet, bar magnet, and ring magnet. You must have noticed N and S written on the bar magnet. What are these N and S? These are the poles of the magnet. The N stands for north and S stands for south. Here S stands for south and N stands for north. So a magnet has two poles, and you can easily see the opposite poles, north and south. They attract each other, and the like poles, the south and north, they repel each other. We will study it further, how the same poles repel each other and different poles, unlike poles, attract each other. Students, as we have studied, opposites attract. Opposite means one is north pole and the other one is south pole. When we bring north pole of one magnet in front of south pole of other, they attract each other. They pull towards each other. This is called attraction. This is called attraction of the poles. When the opposite poles or unlike poles attract each other or pull towards each other. Students, here you can see two bar magnets. They both are having north and south, north and south. Now let's bring the north of second magnet towards the south of first magnet. Let's see what happens. Yes, they are pulled towards each other. This is called attraction. The unlike poles, south and north, attract each other, or they pull towards each other. Now you can see the first magnet with south pole and the second magnet with also south pole. So they are same poles, or we can say like poles. Let's bring the south pole of one magnet towards other. Let's see what happens. Oh, it gets repelled. The first magnet pushes the other magnet. This is called repulsion. When same poles or like poles are brought near each other, they repel each other, or we can say they push each other. So you have understood attraction between poles and repulsion between them. Students, why this repulsion and attraction is caused? This is because of the magnetic field around them. What is this magnetic field? As you can see in the magnets, around these magnets, these are magnetic lines going out from north to south. Magnets have invisible magnetic fields. This is the region around a magnet in which a magnetic force exists. That is known as magnetic force. And magnetic field lines exit from north and enter towards south pole. Now we will perform an activity to see how these magnetic field lines are produced. Are you ready for the activity? So let's start. Students, now we will be performing another activity with the help of this bar magnet and iron filings, which we have used earlier also. We need a white sheet for this. Now, as you can see, the bar magnet has two poles. One is north and the other is south pole. We have already studied magnet has two poles, north and south. Now, I will put this magnet under this page. You can see I have kept this magnet, bar magnet, under this page. Now I will sprinkle these iron filings on the paper. As you can clearly see, the iron filings arrange themselves in circular path, and most of the iron filings are attracted towards the poles, north and south poles, and these circular path, these are known as magnetic field lines. You can see magnetic field lines in circular path, and most of the iron filings are attracted towards the poles of the magnet. Students, I hope you all have understood the magnetic field lines which we have done in the activity. What we have done? We have sprinkled iron filings around this bar magnet, and what we have seen there, the magnetic field lines, as you can see in the picture, they are coming out from north pole and moving towards the south pole. Magnetic fields are invisible, and we have sprinkled iron filings around the bar magnet, and they have aligned themselves in circular path. These are magnetic field lines, and magnetic field is strongest at the poles. As we have seen in the activity, most of the iron filings stick towards the poles of the magnet, where the magnetic field is strongest. Students, you might have seen magnets used in your daily life, like in your pencil box, in your drawers, for closing the door of the fridge. So there are lots of uses of magnets, like keeping the door shut. The mobile covers also have magnets. Pencil boxes which you use also have magnets. It is also used to move heavy objects. For making parts of computers, they are used in fridge, TV, and maglev train. Maglev train uses the principle of magnetic leviation. As you can see, the north poles, the north and north causes repulsion, and here south and south causes repulsion, and repulsion and attraction goes on side by side. This is the maglev train, which uses repulsion and attraction principle of magnets. Students, I hope you have understood what we have studied till now. Now let's juggle your brain and answer the question. Students, we have studied a magnet has two poles. Can you answer? Can a magnet has only one pole? Can a magnet exist with one pole? Just think and explore. Thank you.